Hey everyone, so we're going to work on problem 9-29 right now, and we have this hollowed out cylinder made of steel that has the middle filled with concrete, and we have a force of 80 kilonewtons pointing down, and what we have to do is we have to find the average normal stress in both the concrete and the steel as a result of this loading. So I drew it over here, and so we have that the E of steel is 200 gigapascals and the E of concrete is 24 gigapascals. And we have to find the average normal stress. So we have to figure out how to set this up. So we have to think about this now. As this force points down, both the concrete and the steel is going to push up. So we can incorporate that into our equilibrium equation for y. So you see here the force pointing up as a result of the loading of steel plus that of concrete minus the actual loading. That's going to be equal to 0. So that's our equilibrium equation on the y. But that isn't enough because we don't really know anything about the relationship of the force of steel to the force of concrete. So we need something else. So what we can look at is how much the concrete and the steel are going to be depressed under the loading. And since the concrete is kind of bonded inside the steel, they're going to compress the same amount as a result of that loading. So how you can write that is the displacement of steel is equal to the displacement of concrete. And so we have two equations. We have 4 unknowns, but in reality, this is like 2 unknowns. Because when you look at it, if we were to section, say, this like right here or something like that, the internal force of the steel and the concrete, they're actually going to be the same as the total forces over here. So we can really use the F over here as the P in our displacement equations. So if we go down, we know that displacement is equal to PL over AE. So we have our respective steel on this side and our respective concrete on this side. So continuing that, yeah, that's the same thing, sorry. Or no, it is not the same thing. It is the forces over here substituted for P. So it is the same thing, but it's really not. And then, so what we're going to do now is we have to relate one of the variables to the other. So I chose to do steel, but it doesn't matter. You can choose to solve for FC. But, you just multiply the bottom and then divide the length. So you end up, the force of steel equal to the force of concrete times length of concrete times the area of steel times the E of steel over area of concrete, E of concrete, length of steel. But it turns out that since there's no, length difference, it's a half a meter for both. So the lengths are actually the same. So we can go ahead and get rid of those. Okay, so now it is literally just plugging in numbers. So we keep our variables, F of ST, F of steel, and the force due to concrete. We have the area of steel, which is the outside. So to find the area of this, it's going to be, normally an area of a circle is pi r squared. But since we have part of it hollowed out and replaced with concrete, we're going to do, an inner and an outer radius. So pi times the outer radius squared minus the inner radius squared. And that's what I did right here. And then this is just a simple pi r squared. These were the values given in the problem. And when you multiply all that out, you end up getting that the force of steel is 2.55 times the magnitude of the force of concrete. So we've related the two forces, so we can go all the way back up here. Remember the two forces minus the external loading. That was our y equation. So we know that F of steel is equal to 2.55 times that of the force of concrete. So you get 3.55 times the force of concrete, and you find that your concrete force is actually 22,535 newtons. Finding steel is as simple as subtracting the force of concrete from 80,000, and you get that it's 57,465 newtons. So we're almost done. It's pretty easy after this. We just have to find the average normal stress, and that is as simple as force over area. So we're going to take these force values and divide them by these area values over here. So like I said, steel and concrete, force divided by area. You end up getting 4.88 times 10 to the 7th pascals for steel, and you end up getting 5.86 times 10 to the 6th pascals for concrete. And that's all we need to do.